This is part 2 of convolution neural network. In this video, I will explain convolution operation. The first step to understanding CNNs is to understand convolution. The convolution operation shown in the following figure is very similar to image processing filters such as the Sobel filter and Gaussian filter. The kernel slides across an image and multiplies the weights with each aligned pixel element-wise across the filter. Afterwards, the bias value is added to the output. So this is the input data. This is the image. Computer understands zeros and ones. This is the pixels of the image. And this is the kernel, or we can call it the filter. So this is the weights of the kernel. We do element-wise multiplication. So this is 1 times 1, and then 0 times 0, 0 times 1, and the second row with the second row, and the third row with the third row. Then we sum all the numbers together. So we get 4. So this is the output of the multiplication with the input and the weight of the kernel. There are 3 hyperparameters deciding the spatial of the output feature map. We call this feature map, convoluted feature. The first hyperparameter is the stride, which is the step each time we slide the filter. When the stride is 1, then we move the filters 1 pixel at a time. When the stride is 2 or 3, which is rare in practice, then the filters jump 2 pixels at a time as we slide them around. This will produce smaller output volume spatially. The padding, which is the inputs, will be padded with a border of size according to the value specified. Most commonly, 0 padding is used to pad these locations. In neural network frameworks like Caffe, TensorFlow, PyTorch, the size of the 0 padding is a hyperparameter. The size of 0 padding can also be used to control the spatial size of the output volumes. Another hyperparameter is the depth. The depth of the output volume is a hyperparameter too. It corresponds to the number of filters we use for a convolution layer. The easiest way is to see this in action with a few simple cases. First, in the context of neural networks, convolution is done between tensors. The operation gets 2 tensors as input and produces a tensor as output. The operation is usually indicated with the operator star. Let's see how it works. Consider 2 tensors, both with dimensions 3 by 3. The convolution operation is done by applying the following formula, as I showed here, which is element-wise across the filter.